In this presentation, I will be covering some of the advanced features of SQL Server 2008 R2. Some features will only be talked about as they are already integrated and in use as back-end processes. However, I will be providing a basic demonstration of those features that are provided in Visual Studio 2008. Here are the features that I will be covering. I will only be talking about the first four bullets: high-speed connectors, star join query optimizations, data compression, and resource governors, while I will provide demonstrations of the remaining: change data capture, table partitioning, and policy-based management. First, we will discuss high-speed connectors. The high-speed connectors used were created by Attunity. These connectors provide the ability for SQL Server 2008 R2 to connect to Oracle, Teradata, and other popular data sources. Connectors are fully integrated into the BI Development Studio. The simple use of these connectors can be seen in the diagram below. Objects like Oracle Source provide simple drag and drop capabilities. Behind each object, you can configure the connectors, browse the metadata, and check the routing of any possible errors to detect where hangups occur in the system. Next is star join query optimizations. This is a new feature that was presented in 2008 R2. This feature helps alleviate issues faced when joining tables from very large databases. Star join query optimizations use bitmap filtering to improve the performance behind row retrieval of fact tables. By using bitmap filtering, an average data warehouse query runs 20% faster. By using star join query logic, 2008 R2 automatically detects star schemas in a database, thus providing query efficiency once in use. In order to provide this, rows are filtered before joins are implemented. If a query returns less than 10% or more than 75% of total rows in a table, then bitmap filtering does not apply itself, as there are very few rows that need to be filtered out. Star join query optimization provides the highest efficiency from integers, as it enables bitmap filtering to be applied as part of the initial table or index scan. In data compression, there are two basic types: row compression and page compression. Row compression works within each row of data while providing space reduction that is required to store that data. It does this by calculating the actual byte value being stored for a given column in a given row. Page compression uses row compression while also using prefix and dictionary compression. Prefix compression works by looking for values in a given column that have common beginnings within a page of data. Dictionary compression works last and looks for repeating values within a page. A copy of this value is then placed in the page header, which is used in place of each individual occurrence of the repeated value. Backup compression is also available with no real features involved. It is not automatically implemented and must be turned on before being used. The advantages of backup compression include the reduction of backup sizes and the time involved to complete those tasks. It does have a few disadvantages, however, as it increases CPU usage, which could adversely impact concurrent activities. The resource governor is a cool feature for administrators. This feature enables admins to manage workload and resources by creating limits on consumption. This allows admins to differentiate workloads and allocate shared memory as requested. It also helps prevent runaway queries by allowing you to set caps on applications. At the same time, you can also create distinct groups for applications that are trusted to not crash the system. Change data capture is a very useful feature that provides no bad side effects for its use. The idea behind this feature is to lower overhead of the server while increasing performance. It allows us to store data that has changed since the last update in a data capture table. This feature uses SQL transaction logs in order to provide duplicity of change values as well as speed up reading of those changes. By providing changes in their own change data capture table, Data warehouses are able to pull information pertaining only to these changes from the tables they receive data from, increasing performance and query time. Now I will provide a demonstration of how CDC works. In the Change Data Capture demo, we will get data from our data warehouse, load the CDC data, and then update the data in our data warehouse. I've already set up an SSIS package to show how this works. We start with a SQL query object called getData that loads the tables. In order to set up this object, we have to double click on it. We have to set up our connection, which I've already done so, as well as create a SQL statement, which I've already filled in for us. You can parse your queries, make sure they work before even hitting the play button, as well as build your queries, which once we're done with that, we're going to load our data flow task, which will load the data from the CDC itself. And you can see the data flow task right there. In order to set up the data flow task, you can either go up to the top and click on the tab, or double click on the object itself, which loads the data flow. Here you must set up how the CDC gets its data to and from the data source. I have a simple source destination connection. You can insert a conditional split in between this to add updates as well as deletions if you really wanted to. However, we only want to insert into our database, so we'll leave these out for right now. Finally, to load the data into our data warehouse, we must create a query to update the data within the data warehouse itself. So once again, have to set up the connection for this one and create an update command to update the table itself. And once we are done, I'll click the debug button, and this will take a little bit. However, since I don't have insert access to these databases, it will get hung up at the load data from CDC, which we'll see here in a second. And there it is. And if we look at the progress, you can see that the insert permission was denied. So I'm unable to show more than this. However, if I did have access to it, this would load the change table into the data warehouse. Table partitioning is also a new feature that provides ease of management as well as better performance in querying and processing. Each fact table that is detected from star join query optimizations is automatically created as a partition in each cube. Each fact table can be broken down into further partitions in order to break data apart. For example, sales data from 2007 can be broken down into 1, 2008, 2009, so on and so forth. Ultimately, partitions could come from different databases entirely if the dimensional measures are the same. This provides for seamless integration of data from multiple databases. I will now provide a demo of the basic features of table partitioning. In the table partitioning demo, I will show how to partition the data from a star schema. To start, you must have already created a data source as well as a data source view. Once both are created, we need to make new name queries inside the data source view, which will become our partitions themselves. So you can see here I've already created 2 item fact tables based off of new name queries. In order to create your own new name query, all you have to do is right click with anywhere within this square, and you can create a new name query by left clicking. I'll show you what the new name query looks like. You can put in the name of the query, a description, as well as provide the select statement. Once the select statement is created, the query definition is generated in a preview screen, as seen here. Once we are done creating both of our tables in the data source view, they can further be created as partitions within our cube. I've already created the cube for us. As you can see here, the item scan fact table is already shown as a partition. Every single cube already holds a partition based off the fact tables that are available within that cube. So if there's more than one, say there are two, there will also be two partitions already created. In order to create a new partition based off the new name queries that we just created, we just click on the new partition button. It brings up a wizard. And as you can see here, these available tables are pulled straight from the data source view. So if they aren't showing up, you've done something wrong within the data source view in creating those queries. So I'm going to click on our Vata here. Go and click next. We want to design our aggregations later. Don't want to do that right now. And there's an issue with saving while the storage mode is not MOLAP, so we'll fix that, and we will run our processes. It'll allow us to save, run our processes, and now that is a part of our partitions. There is also another issue. This status is not updated. It has processed, as you could tell. I just processed the item fact Arvada, and it is also showing two partitions already, so it is updated to two partitions. However, as you can see, there are still a few bugs in this process. Once I've saved it, however, I can go back to storage settings and change it back to medium latency, and it won't throw me an error. And since it's bound to a name query, I have to change the notifications to a tracking table. We'll track it back to the item scan fact table, which is a part of the schema. Click OK, 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 and then we can process this as well, and then both partitions will automatically process on their own. Now I'll show you the error that I'm talking about with the last partition. We'll create the Texas partition. Don't want any of this. We do want to design aggregations later. That's the only real step. And now, if I see storage settings for this, you can see it's already medium latency. So once I try to process it this time, it's going to throw me an error, which I don't understand entirely. It just seems to be a bug. So in order to fix this, we just have to go back to the storage settings and then try to process it again, and it'll work. And this partition's a little bit bigger, so it's going to take a little bit longer. And then we're done. That's how to create a partition. Finally, policy-based management provides the ability to define and enforce policies for configuring and managing SQL Server across an entire enterprise. A couple of definitions include target, facet, condition, and policy. Each one of these is involved in the creation of a condition and policy. I will now be demoing the creation of a condition and policy. The final demo covers policy-based management. In this demo, I will show you how to create a condition and a policy. In order to use policy-based management, you must first be using SQL Server Management Studio. I will now show you how to navigate in order to get to the policy-based management. First, this is the basic tree of any database. At the very bottom of any database, you should find a management folder, which once we click on it, you can find policy management within that. And below policy management, we have policies, conditions, and facets. If we pull apart conditions and policies, you can see we don't have any right now. However, if we click on facets, we are able to see every single facet imaginable in the database. So first, we will create a condition. Since policies are based off conditions, you cannot create a policy without first having a condition. So this is a very important piece of creating a policy. We will call this the auto shrink condition. And the facet we want to use is a database. Based off which facet we select, this field is auto-populated based on what we would like to do. So for our database, we would like to auto shrink. We would like to turn auto shrink off. And since I don't have the proper credentials to finish this process, I'm unable to create the new condition. However, this completes the creation of a new condition. So once I click on OK, we'll see that it didn't work. But if I had the correct credentials, I would be able to do this. With policies, as I was saying, we can create a new policy called auto shrink off. Based off that condition, we were wanting to create a policy that turns off auto shrink when it is in use. And under the check condition, we would find that condition we have just created. However, since it didn't work, it's not under here. We can create a new condition, which is a pretty cool feature. Doesn't leave you at a dead end, which is what I have right now. However, once that is created, it shows us the against targets, which it will show every database. You can click on the every as well as the database. The every can be changed to an individual database, as well as the database can be changed to table. So you can put every table, an individual database, so on and so forth. Finally, the evaluation mode shows how often the condition is defined. So in the evaluation mode, we would have on demand, which is the default mode, on schedule, which we can schedule it according to a calendar, or on change. The on change has two different features: log only. The on change log only evaluates the policy only whenever the properties in the facet have changed, and any violation is logged in a Windows event log. The onChange prevent evaluates the policy whenever the property is changed and actually prevents the change. And once you have decided upon your evaluation mode, we are done. And this finishes the creation of a condition and a policy.